Okay, so as we said, John Maple,
Hey.
yay, Frank Summers, me, Joey, Mitch Watkins, and Zolt LeVay will be here to give you a special talk around 9:30 today. All right, we are the home of, the science home of Hubble. If we say we're the home of Hubble, folks here at Goddard get really annoyed at us, okay? Simply because they are the, they run the telescope, we run the science program. We both call ourselves the home of Hubble colloquially, but if you want to get specified, they run the telescope aspect of it, we run the science aspect of it. This is our boring building up in Baltimore on the Johns Hopkins campus. People come in and say, ooh, it must be really cool, you work on Hubble, and it's just geeks sitting at computers, okay? No, but honestly, people have come in and say, can we come in and see the telescope? And you have to say, all right, what part of space telescope do you not understand? So here is Hubble out in space. It's about, 350 miles above your head, 600 kilometers on order up. It orbits once every 97 minutes. So during this, that's about 16 orbits a day. So during the week here, it'll make, 16 times 5, that's 80 orbits over the course of this week, okay? So you can think about Hubble just orbiting all the time while we're talking here. All right, so what do we do? Well, we operate the telescope in scheduling the science observations of the Hubble Space Telescope, okay? The Hubble Space Telescope has been up for how many years? 25. Sit in the front of the room, she knows the answers, 25. We know, what?
It was on the pre-thing.
It was on the pre-thing. Okay, good. 25 years of Hubble, all right? Operates the telescope, okay? Now, you might think that there's somebody with a joystick actually controlling the telescope. Of course not. It's all computer controlled. Astronomy telescopes have been computer controlled since the 1980s. Basically, as soon as we can get the computers to control them, we did, simply because you really want to point these things accurately. The other thing is that Hubble is a very, very valuable resource. This is a telescope we spent like $4 billion over its 25-year lifetime. We want to get every ounce of science out of it that we can. So we schedule the observations very carefully so the telescope, does an observation, slews a little bit, does another observation, and so that the time in between observations is minimized. When Hubble first went up in 1990, the time between when we uploaded the commands to when those commands were executed was 60 days, actually 57 days. So 2 months in advance, we had to know what we had to decide what the telescope was going to do that day. We've now got it down to 11 days. Okay, that's what computer optimization, solving essentially the traveling salesman problem over and over again for 25 years has gotten us down. That we now schedule the telescope about 2 weeks in advance. It's gone from 2 months down to 2 weeks in advance for scheduling these observations. Okay, that is what our scheduling group does. We used to develop instruments for Hubble, but Hubble will no longer be serviced, so there are no more new instruments for Hubble. The last servicing mission 4, was in 2009, May of 2009, so there are no more new instruments, although we are helping develop instruments for this one over here, which we'll talk about in a second. All right, we have astronomers on staff. What it used to be in the old model of supporting a telescope was that a university owned a telescope, and so the scientists at that university developed all the instruments, developed all the support for it and everything, and came up with these things. We changed that model so that we have astronomers on staff at Space Telescope Science Institute, and they get half time for research and half time for telescope support. So this has turned out to be an amazing model. So the people most interested in the telescope are also those writing the handbooks, developing the instruments, developing the software. So that the folks in our building have a vested interest in Hubble succeeding because they're not just running it, they're also using it. And that's proven to be the standard model now for national observatories. Future missions, we work on a lot of them. The one that's coming up is the James Webb Space Telescope that will launch in 2018. That is the next of NASA's great observatories. You'll hear plenty about JWST this week. We're also involved in some much longer range things. There may be some press today of something about an HDST, High Definition Space Telescope, which is the current acronym for what used to be called At Last. I don't know if you...
Oh, yeah.
Yeah, it's now become HDST.
Is that the one that Roland's in charge of?
Huh? No, he's W first.
Okay.
Okay.
They all sound
Yes.
the same.
Anyway, so there's lots of acronyms for upcoming telescopes in the 2020s. There is a huge press event at American Museum of Natural History in New York today. The release of the report on the HDST and those future missions will come out today. And actually, they're not going to get smunched by Pluto, because Pluto went to, the New Horizons mission to Pluto went into safe mode on Saturday. It went into safe mode on Saturday. There was, quote, quote, an anomaly, all right, which is code word for something happened. It went into safe mode. They have just released a press release this morning that I saw as I was checking my email, that the anomaly was related to some uploading of some software and some timing, and that this will not occur again for the rest of the mission. So they don't expect this anomaly to occur again. New Horizons flies past Pluto on July 14th. All right, and there's all sorts of cool stuff you'll learn about tomorrow. All right, and also use the data. Well, actually, we store the data. Every single bit of Hubble data that comes down from the telescope goes through White Sands, New Mexico receiving station, goes here to Goddard Space Flight Center. They keep an archive here, level 0, level 1, and I don't know how many levels they keep here. And then they send it on up to us. We then do much more processing and then distribute the data out to the scientific community. So if you're an astronomer who wants to do time on Hubble, you come to us first to even get time, and then you come to us to help you utilize your time best. And when your data, you come to us to get your data. All right, that's what being a science home of Hubble means. All right, all the interactions with the scientists using Hubble come through us. Okay, we have the full archive there, and that archive is 100% public. Well, actually, I'll say 99.99% public. There is one exception where you can't get the data, and there's a proprietary period for 1 year. If an astronomer goes through the entire huge and really expensive, detailed and time-expensive process of getting time on Hubble, they get the data for 1 year. All right. It goes into the archive. They get an email that says, "Hey, it's your data." All right. They can utilize that data only only they can utilize that data for 1 year, and then at that 1 year, the switch flips and it becomes public. So every single bit of data from 24 years of Hubble is available publicly. Only stuff within the last year might be still under proprietary time. A lot of the stuff these days also has no proprietary time. So this is another reason how your tax dollars benefit from having a publicly funded telescope, is that scientists across the world can come to our archive, pull out old Hubble data, and do new science with it. We are getting 50% of our papers, scientific papers, coming from the archive access, and 50% from current telescope time, which is really good. That, you know, half the science from Hubble comes from stuff that people didn't think of when they wrote the proposal. It's post-processing of those proposals. All right, we in the Office of Public Outreach are responsible for communicating the excitement of the universe to the education community. Are you excited?
Yay.
Well, maybe you will be by the end of the week, okay? That's as best I can do for Monday morning, okay, guys? All right, we'll get there. We'll get there. All right, so we basically say that we've got the latest images from Hubble and how you can use them in your classroom. We have a whole variety of ways. As you notice that we have one astronomy teacher in here. Astronomy is not huge in the American high school curriculum or American school curriculum. It's big in college because everyone likes to take it because they think it's the easy science class, right? It's not, but that's what, because it's pretty. People like to think it's the easy science class in college. It's not very much in high school. So we have to use lots of different ways to get it in there, okay? And you'll see that we do use math, and we do use English, and we do use history. We do all these other things to get it in there. We'll show you how we do that, okay? And most importantly is that John and I work together, okay? He's the educator. I'm the scientist. Usually I do this with Bonnie, but you know, the point is that
Our offices are right next door.
Yeah, right, they really are. As an educator, he doesn't know the details of the science. As a scientist, I don't know all of the pedagogy of education. By working together, we can benefit your community better. All right, and it's not something that we just spout as a coda. You know, this is our scientist-educator partnership. No, we live it because I have learned so much from them. They learn so much from me. Without that partnership, we're not terribly useful. Okay. And so you'll see lots of pictures of us doing things together. All right. The other thing, of course, that is useful is to actually find out what your community needs, okay? And so here is what our K-12 educators told us that they want: materials that can be modified for the classroom, supplemental materials, stuff to engage students, modular activities, stuff from, if I give you a whole, thing that you can do in a week, you're probably not going to be able to fit a whole week's worth of stuff in. But if you want to take one module and say, I got 30 minutes here, I can throw this in, that'll be really cool. Or I can throw it in here, or I can string a few of these together. If I got a couple class periods I can devote to it. That's what we like to try and do. Doesn't always work out, but we do our best. Okay, we try to be user friendly. We try to turn it into your language as well, all right? And how to take the current stuff into the classroom besides just putting the picture up on the bulletin board, okay? Let's try and go a little bit more than that. And of course, these specific topics, okay? That it's not we have a message that we want to get out to the public, we're trying to use you as a distribution vehicle. It's really, you have topics you have to cover. How can we take our science and fit it into the topics you already have to cover? Which is very important. You'll find, unfortunately, a lot of science outreach is like, hey, we've got this really cool mission and it's gonna do this really cool stuff and we want you to tell the kids about this really cool stuff. And you go and say, well, how does that fit into what I'm already teaching? All right, we wanna try and take what you need and fit our stuff into it. We'll do a little bit of the other stuff too, but you'll recognize when we do that. All right, so we have teaching tools by type. Graphic organizers, Q&As, science content reading material, online explorations, the stuff, PowerPoint presentations, and so on. We also have them by topic, okay? Gravity, if you're teaching something where you need some gravity, or math, we have some statistics stuff. We have the electromagnetic spectrum, which is what you will see today. Today's focus is going to be on the electromagnetic spectrum, all right? This is our website. It's called Amazing Space. You type that into any search engine, you will find us. Don't worry, you'll get lots of references to amazingSpace.stsi.edu during the week, okay? We talk about targeting K through 14 because Astronomy 101 is so big in college. That's why we talk about K through 14. We do a bit of informal science education supporting museums and planetariums. Astronomy is also a blessed science in that they have a network of science museums that do astronomy and planetariums. So helping them get science into their content, into their presentations is good. And of course, it's open to the general public. Now, one thing that you will find out this week is that there is a For Everyone button on Amazing Space, and then there is a For Educators and Developers button. We do not have a password locked For Educators and Developers button. So your students, if you use stuff on Amazing Space, your students, if they are the wily ones who say, oh, let's go see what the For Educators and Developers, and see, oh, here are all the teacher pages. Well, the teacher pages are available publicly. Yes, your students can find the teacher pages. We don't have a good solution for that because we've got to get it out to everybody, and it's not like we can distribute a password that only teachers are allowed to use. Yeah, so if you can come up with a solution that's better than that, can do that, let us know. All right. Okay, what else? Hubble resources in the classroom. What is this set of slides about? Oh, just to give you examples of how we go to various things. Okay, so for the science classroom, we have graphic organizers talking about spiral galaxies, elliptical galaxies, and irregular galaxies. Here's the similarities and differences amongst those. Again, a teacher PDF and a student PDF sitting right there. Okay, we do that same sort of thing as a Venn diagram. This warped galaxy here versus this whirlpool galaxy here. What's different and what's the same? We have myths versus realities, also known as misconceptions. One of Bonnie's favorite topics bang on and bang on and bang on is getting the misconceptions out of your students' heads before they start trying to pile in new knowledge. Astronomy there's a lot of misconceptions. I wonder where they come from. Okay, there's a new Star Wars film coming out this December, right? So many of them come about that. Presenting what is a myth and what is real is important for us to try and help get those ideas out. We do lithographs. These is the Hubble Ultra Deep Field. Nice, pretty picture. You can just take it up and put it up on the thing. Yes, but on the back, oops, it doesn't show on the back. Okay, another slide set that I've got. On the back of this, there's also information about it, okay? About 350 words telling you the science behind it, as well as for every lithograph we do, we have a teacher page that says, here's how you might be able to use it in your classroom in an inquiry-based learning setting, okay? Getting people to think about what they're looking at, ask questions, do some math, whatever. They have all sorts of things. Gesundheit. All right, we also have one of our most popular things on Amazing Space is the Tonight Sky. People love to go out and astronomy clubs look it up. We have a monthly video that you can download that says, here's the highlights of the night sky. And this is incredibly popular. It's always one of the top 5 on our YouTube channel every month. But we also know that we have to get into other classrooms to get there. In language arts, we do something called the Star Witness News, where we take the discoveries from Hubble, we write it at, what is this, about a 5th or an 8th grade reading level, John?
8th grade.
8th grade reading level? Okay.
Yeah.
So we can talk about the Hubble discoveries in detail, sort of like my weekly reader, but for Hubble and other astronomy things. So we have that available online, as well as in a PDF you can download and print out and use in your classroom, or just use the PDF online. We do some things for math. One example is our Hubble Deep Field Academy, where we do some statistics about the number of galaxies in the Hubble Ultra Deep Field, which you can therefore then promulgate to the number of galaxies in the entire universe. In one class period, your students can go from looking at a picture to estimating the number of galaxies in the entire universe. And that's a really cool, it's really cool for them to see that at the end. Plus there's some classification and distances and such, and so on in there. For history, we do, for the International Year of Astronomy, we did a series of posters that basically it was a small traveling exhibit that went to libraries around the country, like 75 libraries around the country. One is still stuck in Utah. The folks in Utah will not let it go. They keep taking it around from school to school to school and displaying it. This basically takes one topic, explores how it has changed from Galileo's first telescope to what we know today. So you can see the old time drawings, and here's all the new things, the understanding that we've gotten about Saturn's rings over 400 years. So we do a little bit of history there. Yeah, here it is in one of the libraries. It's also been in lots of schools. We do have PDFs that you can download and print out should you want to do that. We also, you'll hear a lot about this on Friday, telescopes from the ground up. Another thing, tracing the history of telescopes out there. We found that there was very few to none good websites telling about the history of telescopes. So we just went and created our own for that. We do a lot of professional development, such as we're doing today. We got lots and lots of workshops that we do, and a certain number of the PowerPoint slides for this will be up. By the way, sometime late this week or early next week, I will have every PowerPoint that we use in this entire week up on a website where you can download, okay? So if you like to use PowerPoint in your classroom, you want to steal all our slides, your tax dollars are paying me to do this, so we give them away for that, okay? For information, do not contact me. Talk to him. He's much more responsible, okay?
But I will ignore your email.
No, you can contact me, and especially if you say that you were in the Pennsylvania workshop and you have a special question for me, I will answer that. Some of the emails I get that are from random people I don't have time to answer, but you guys are special, so you definitely do get an answer in my email, okay? All right. And so there is our Hubble Space Telescope. Is that it? All right. Anything else we need to say to them this morning, John?
Nope.
All right.